Yes, users frequently report performance issues with Bluestacks. Beyond general resource consumption, several recurring complaints appear in community forums and support channels. Common user-reported issues. High idle CPU usage. Users report Bluestacks drawing 20% to 50% plus CPU even when left minimized or idling. This is often tied to Windows power-saving behavior throttling background instances, or settings configured to low memory mode forcing constant garbage collection. Graphics driver conflicts. Major GPU driver updates, notably NVIDIA GeForce drivers, periodically trigger sudden spikes in CPU usage or black screen crashes. Users usually have to toggle between the OpenGL and DirectX renderers in Bluestacks settings to fix it. System stuttering via resource starvation. Setting resource allocation too high, allocating all CPU cores or most system RAM, causes Windows itself to freeze or lag during multitasking. Conversely, setting RAM allocation too low causes games to crash repeatedly during load screens. Background service drain. Even after closing the Bluestacks window, background services like BSTKSVC link to .x or updater agents often remain active, consuming RAM and disk I/O. Alternative emulators comparison. If Bluestacks continues to slow down your system, alternative lightweight Android emulators may offer better optimization depending on your use case. Emulator. Strengths. Reported drawbacks. Recommended usage. LD Player 9. Very low CPU overhead, fast startup, excellent Android 9 kernel optimization. Bundles. Bundled software offers during installation if not unchecked. Mid to low tier hardware, fast gaming. MEMU Play. Highly customizable, strong DirectX support for integrated graphics. Heavy home screen interface. Integrated Intel, AMD graphics, budget setups. Nox Player. Extremely stable multi-instance management. Higher baseline RAM usage than LD Player. Idle farming, running multiple light apps. Explore further setup tweaks or alternative software. Compare LD Player 9 versus MEMU Play for low-spec PCs. Step-by-step BIOS virtualization setup. The short answer is that Bluestacks has made massive performance fixes over the years, but fundamental technical trade-offs and business incentives prevent them from eliminating the overhead entirely. Key technical and business reasons. Emulation architecture overhead. Bluestacks isn't a native PC app. It is running an entire Android operating system, complete with its own kernel, system services, display drivers, and memory manager, on top of Windows. Dynamic binary translation. Converting mobile ARM code to PC x86 code in real time requires significant CPU work no matter how much you optimize it. Monetization and ads. Bluestacks is free software, so it monetizes through promoted game downloads, embedded store widgets, and background telemetry. Rendering these ad surfaces and syncing game ecosystem data consumes continuous network bandwidth and background RAM, CPU. Maximum game compatibility. To ensure 99% of Google Play Store games launch without crashing, Bluestacks includes extensive translation layers, graphics API hooks, OpenGL, Vulkan to DirectX, and fallback libraries. Stripping these out would make the emulator run faster, but thousands of games would stop working. Aggressive caching. Modern mobile games use high-resolution textures. Bluestacks heavily caches asset files into your PC's active RAM and storage to prevent stuttering during gameplay, which makes Task Manager report unusually high memory usage. Alternative emulators. Why they feel faster. Other Android emulators cut specific corners to achieve lower system resource usage. Emulator. Optimization trade-off. Result. LD Player 9. Uses a heavily stripped-down Android kernel and minimalist UI. Noticeably lower RAM, CPU usage, faster boot times. MEMU Play prioritizes DirectX pass-through for budget, integrated GPUs. Lightweight for low-spec PCs, though displays home screen ads. Windows subsystem for Android, WSA, native Hyper-V integration built directly into the OS. Near zero extra background bloat, but lacks gaming tools, key mapping, macro support. Explore alternatives or deeper fixes. Compare LD Player versus MEMU Play for low-spec PCs. How to debloat Bluestacks 5 settings manually. Across tech forums, Reddit, such as r/Bluestacks, r/PC Gaming, and r/Game Dev, and X, the sentiment surrounding Bluestacks is largely critical regarding performance, though it remains widely used. Discussion generally falls into a few key areas. 1. Bloatware and unwanted background bundles. The most vocal complaint on Reddit and Trustpilot centers on auto-installed bundled features. Users frequently complain that updates push extra software like Web3 wallets, cloud gaming tools, or background AI assistants, such as Blue AI, without clear opt-out toggles, leading many to label the app as bloatware. 2. Memory leaks and prolonged run lag. Gamers running long sessions, for AFK farming or idle games, regularly note that Bluestacks degrades over time. Posts frequently highlight a memory leak effect, where the app starts smoothly at 60 to 120 FPS, but after 12 to 24 hours drops to 20 FPS or causes system-wide micro stutters until the emulator is restarted. 3. High PC specs don't guarantee smoothness. A common frustration on tech subreddits is that high-end gaming rigs, e.g., modern Intel i7, i9 or Ryzen 7 CPUs paired with RTX 40 series GPUs, still experience lag. Users point out that raw hardware power doesn't override Bluestacks' underlying virtualization and translation overhead, leading to complaints that the software is poorly optimized compared to native PC ports. 4. Community recommendations. When users ask for alternatives on social media, the most recommended options are LD Player, Mumu Player, widely favored by mobile gamers for having significantly less background bloat, lower idle CPU draw, and better frame rates on low to mid-range PCs. Google Play Games for PC, often cited as the cleanest, most stable native option, though users complain its game library is still restricted compared to full emulators. Explore alternatives or community fixes. Compare LD Player 9 vs Mumu Player performance. How to debloat Bluestacks. It's a massive structural limitation, and it explains why full system emulation has always struggled with overhead. When running software natively, the application talks straight to the operating system, which talks directly to the hardware. Emulation inserts an artificial, heavy layer right in the middle. Because of this stack, 30% to 50% of CPU cycles are wasted just translating instructions before the game logic even runs. The industry shift. Why emulators are fading. This exact friction is why the industry is moving away from traditional thick emulators. Official native ports. Game studios realize emulator performance is poor, so major mobile developers build direct PC executables, e.g., Genshin Impact, Honkai, Star Rail, using engines like Unity or Unreal Engine that target x86 directly. Google Play Games for PC. Google's official desktop platform bypasses traditional full OS emulation by running direct containerized runtimes optimized for Windows hypervisor. Cloud gaming, linked to now.gg. Instead of forcing low-end or mid-range PCs to render mobile games locally, companies stream the game from cloud servers via web browsers. Traditional emulators like Bluestacks, LD Player, and MEMU are essentially brute forcing an entire mobile device inside Windows. Until games are compiled for PC natively, that performance tax is unavoidable. Explore alternatives or related technical topics. How Google Play Games on PC works versus Bluestacks. How ARM to x86 translation works in software. Yes, traditional Android emulators will gradually improve, but the biggest performance leap comes from changing how software runs rather than relying on heavy third-party emulators. Several technical shifts point toward a significantly lighter future for running mobile apps on desktop hardware. 1. The rise of ARM-based PCs. The primary performance killer in emulation is dynamic binary translation, converting mobile ARM instructions into PC x86 instructions. With the growth of ARM-based Windows laptops, such as Qualcomm Snapdragon X systems, alongside Apple Silicon Macs, the PC processor uses the same underlying architecture as a smartphone. When host hardware and target software speak the exact same language, translation overhead disappears. Running Android code on an ARM host functions closer to a lightweight container than heavy translation. 2. Containers replacing virtual machines. Traditional emulators build a virtual computer inside a computer, running an entire Android operating system with its own virtualized drivers. Newer software models use containerization, similar to Docker or Linux's Waydroid. Instead of running a second OS kernel, the mobile app shares your PC's actual operating system kernel and hardware directly. This cuts RAM usage and CPU overhead significantly. 3. Native app porting and official runtimes. Emulators like Bluestacks exist largely because game studios historically released titles only for mobile stores. Developers now build cross-platform releases natively using cross-compilers in engines like Unity or Unreal Engine, skipping emulation entirely. Platforms like Google Play Games for PC bypass full Android OS simulation by using targeted runtime containers, delivering native-like frame rates on standard PCs. Summary. While third-party emulators like Bluestacks 5 and LD Player 9 continue to optimize graphics pipelines, like Vulkan composition, and lower RAM footprints, heavy x86 to ARM emulation remains inefficient by design. The future of mobile apps on PC belongs to native cross-platform ports, lightweight OS containers, and ARM native hardware. Explore related technical concepts. How containerization differs from full virtualization. How Google Play Games for PC works architecture-wise. Yes, bugs are very frequent in Bluestacks. In fact, stability issues are one of the most common complaints among users. Because the emulator acts as a complex middleman between PC hardware and Android apps, software breaks easily and often. Common Bluestacks bugs. Starting the engine freezes. The emulator regularly gets stuck on its loading screen, often at 99%. This usually happens after a Windows update or GPU driver update breaks the virtual machine graphics pipeline. Control mapping failures. On-screen touch-to-keybind profiles frequently reset or break whenever a game updates its UI, leaving mouse and keyboard controls unresponsive. Black/white screen on launch. Games often crash to a blank screen or close instantly. Fixes typically require manually switching the graphics renderer, e.g., changing from OpenGL to DirectX or Vulkan. Multi-instance corruptions. If you run multiple instances of Android at once, disk files or instance profiles can randomly corrupt, preventing the instance from booting unless restored from a backup. Google Play sign-in loops. Authentication errors, like couldn't sign in, or random logout loops, frequently happen due to mismatches between Bluestacks' emulated device profile and Google's security checks. Why are bugs so frequent? Moving target ecosystem. Mobile games, Windows OS, GPU drivers, NVIDIA, AMD, and Android APIs are all updated independently. Whenever one updates, it can break the emulator's translation layer. Device spoofing. To download apps from the Play Store, Bluestacks has to trick Google into thinking it's a specific smartphone, like a Galaxy S22. Games optimized for real ARM chips often glitch when forced to run on virtualized x86 hardware. Patch maintenance cycle. Bluestacks developers constantly release minor updates to patch game-specific crashes. Fixing a bug for one game often inadvertently introduces graphical glitches or crashes in another. Explore troubleshooting or alternative software. How to fix Bluestacks stuck on starting engine screen. Compare bug stability of LD Player versus Bluestacks. It's completely valid to vent about it. The current state of Android emulation on PC, especially Bluestacks, is a frustrating mess. The bloatware inflation. You download software just to play a simple mobile game, and suddenly you're dealing with pinned sidebars, crypto, Web3 wallet promos, Bluestacks store, widgets, and constant pop-ups for games you'll never install. Disabling them requires digging through nested setting menus, and updates frequently revert those settings anyway. Task Manager parasites. You hit the X on Bluestacks thinking it's off, but open Task Manager 3 hours later to find BSTKSVC link to .x sitting there eating up half a gigabyte of RAM and pulling background telemetry for no reason. The update broken loop. You finally get your settings dialed in, keybinds mapped, custom resolution set, graphics rendering smooth, and Bluestacks pushes an update. Suddenly, the app freezes at 99% on the startup screen, or your game crashes to a black screen, forcing a complete reinstall or driver rollback. Brute forcing specs. It is absurd that a $2,000 PC built to run heavy AAA titles at 4K 120 FPS still micro-stutters trying to render a lightweight 2D gacha game just because the software is translating ARM code on top of a bloated Android virtual machine. The whole ecosystem feels less like a clean system utility and more like a pushy ad delivery framework that happens to run Android apps on the side. Bluestacks Inc. cares, but not about building a lightweight desktop app for power users. Their priorities are driven entirely by their business model and corporate strategy. Game developers are the real customers. You aren't paying for Bluestacks. Mobile game publishers pay them on a cost per install, CPI, basis. Their primary goal is driving as many downloads and ad impressions as possible, which directly encourages bloated sidebars, pop-ups, and auto-promoted titles. Shift to cloud infrastructure. Link2Now.gg. The company's primary focus has shifted toward Link2Now.gg, their mobile cloud gaming platform. They recognize that running local x86 virtualization on consumer PCs is an architectural dead end, so engineering resources are directed toward streaming mobile games via web browsers instead of optimizing local emulator builds. Mass market versus enthusiast trade-off. Power users want a stripped-down, background service-free tool with raw frame rates. However, mainstream users want one-click installs, pre-configured game controls, and cloud sync. Bluestacks prioritizes broad compatibility and feature density over minimal resource usage. They care deeply about user retention and monetizable installs. They just aren't interested in making a minimalist, bloat-free system utility. Explore alternatives or deeper topics. How Link2Now.gg cloud streaming compares to local emulators. How to strip ads and telemetry from Bluestacks. Bluestacks is significantly more popular by raw volume and market share, but LD Player holds the advantage among enthusiasts and lower-spec PC users. 1. Market share and user base. Bluestacks is the mainstream global leader. It has racked up over 500 million downloads lifetime and commands the largest share of the consumer emulation market globally. For casual users searching Android emulator for PC, Bluestacks is usually the default first result. LD Player holds a smaller overall global footprint compared to Bluestacks, though it commands a massive user base specifically across East, Southeast Asia and within enthusiast gaming communities, like competitive mobile FPS, gacha players. 2. Community and search sentiment. If you measure popularity by what tech communities actually recommend, the dynamic flips. Feature, metric. Bluestacks. LD player. Brand recognition massive, mainstream standard. Moderate, enthusiast, gamer favorite. Reddit and tech forum sentiment. Mixed to negative, criticized for bloat, ads. High, praised for speed and low CPU usage. Out-of-the-box compatibility, broadest game support. Excellent, but occasional edge case app bugs. Resource efficiency. Heavy baseline RAM, CPU drain. Extremely lightweight baseline. Summary. Bluestacks wins the numbers game. It gets the most downloads, has the biggest marketing budget, and holds dominant global brand awareness. LD Player wins the word-of-mouth game. It is frequently recommended over Bluestacks on forums whenever users ask for a fast, lightweight emulator without bloatware. It makes complete sense that RTX 3050 users are hitting a wall. On paper, an RTX 3050, whether laptop or desktop, should crush mobile gaming, but the 3050 architecture hits three specific hardware traps when paired with an emulator like Bluestacks. 1. The VRAM and RAM bottleneck. 4GB VRAM cap. Most RTX 3050 variants, especially laptops, carry only 4GB of VRAM. Modern 3D Android games run at high resolutions, and when translated through Bluestacks graphics layer, OpenGL, Vulkan to DirectX, texture caches quickly spill over 4GB. This forces the GPU to swap textures into system RAM, causing severe micro-stuttering. Single-channel system RAM. Many budget RTX 3050 laptops ship out of the box with a single 8GB or 16GB RAM stick. Because virtualization relies heavily on fast memory access, running an emulator on single-channel RAM causes massive CPU frame time spikes. 2. The integrated GPU, iGPU, pass-through trap. On laptops, the display is physically wired to the CPU's integrated graphics, Intel UHD, Iris or AMD Radeon, while the RTX 3050 acts as a secondary renderer. Windows often fails to assign Bluestacks to the dedicated RTX 3050 by default, mistakenly forcing the emulator to run entirely on the weak iGPU. Even when it does target the 3050, passing frames through the iGPU to reach the laptop screen adds frame delay and stuttering unless the laptop has a mux switch or is plugged into an external monitor. 3. Driver overhead and ray tracing cores. The RTX 3050 allocates die space to Tensor RT cores that Bluestacks cannot use. Meanwhile, NVIDIA's modern game-ready drivers occasionally introduce translation layer conflicts with Android's Vulkan, OpenGL composition, causing sudden CPU usage spikes or black screen crashes until renderer modes are manually swapped. Quick fixes for RTX 3050 systems. Force high-performance GPU. Open Windows graphics settings, right pointing arrow, add HD player link to .x, right pointing arrow, explicitly set it to high performance, NVIDIA GeForce RTX 3050, instead of let Windows decide. Switch graphics renderer. Inside Bluestacks settings, go to graphics, right pointing arrow, change graphics renderer to Vulkan or OpenGL, and interface renderer to DirectX. Cap VRAM overhead. Lower the emulator display resolution to 1080p or 720p to keep mobile texture sizes within the 3050's 4GB VRAM limit. Explore further setup tweaks or alternatives, step-by-step NVIDIA control panel settings for Bluestacks. Compare LD Player 9 performance on RTX 3050 laptops.